Well, hey there, it's John here back in the Eastman Discovery Lab at the Hands-On Discovery Center with another activity that you can do at home using soda cans, soda bottles, and my favorite chemical, dihydrogen monoxide. Today, the name of the game is buoyancy. What things float in water and what things sink to the depths. We're going to first look at my buoyancy tank here, which is of course filled with water, and check out two different types of soda pop. Here we have the full calorie real soda, and this one is the sugar-free alternative. Starting with the regular sugary one, you can drop it into the water bath, but actually on the bottom there, it might capture a little water bubble that might interfere with its floatability. So put it in kind of at an angle so it fills in that little nook on the bottom and release it. In 3, 2, 1, go. Oh, straight to the bottom it goes. Because it is full of sugar, it's actually way denser than the water that it's moving out of the way or displacing. We can actually scooch that to the side and see if the sugar-free one does the same thing or different. Again, put it in kind of at an angle so you don't trap that air bubble and release it in 3, 2, 1, sink or float. Unlike the full sugar version, the sugar-free one actually floats. As I said, the sugary one has about 40 grams of sugar in it. That's about 9 of these sugar packets that are weighing it down and making it way denser than the water. So it will sink right to the bottom, whereas the sugar-free one will float. But what is it possible for something to both float and sink? That's a good question. And one dude named René Descartes, a French scientist and mathematician, philosopher, he actually came up with an idea for, well, he didn't call it a toy. It's a scientific principle of something that will sink and float. Here, I've made one of these Cartesian divers out of a little eyedropper. You'll want to kind of fill it up with just enough water that it will barely float above the surface. And this one will want to kind of tip over. So I've added a little weight to the bottom here and also embellished it, made it look like a little squid. Then you put it into the soda bottle and it will float because there's that little tiny air bubble on top. But watch what happens when you squeeze the bottle. Oh, all of a sudden he dives to the bottom. When you unsqueeze it, release it, he jumps back up. The reason for this is when you squeeze the bottle, you can actually compress that tiny bubble of air inside of our Cartesian diver, making its volume a little bit smaller, making it more dense. So when you squeeze it, he sinks. When you release it, he rises. You might not have an eyedropper at home. If you do, make it. It's so much fun. But you can actually make one using some simple things that you probably have laying around the house, like a drinking straw. This one happens to be a bendy one, which is ideal, and some paper clips. All you have to do is bend the straw in half like that, and then trim off so that the two ends are about the same. Boop. This is going to be our container that holds a bubble of air. Then start adding paper clips to the bottom. This will add weight, so it kind of stays upright in there. And I've found out that a straw about this size takes about 6 paper clips. Here, I've already made one before you guys got here. Then when you add it to our buoyancy tank, it will barely bob just the smallest bit above the top of the water. So it is ready to go. You'll also notice, if you look very closely, one of the paper clips I've actually bent into kind of a little fish hook shape. I've also taken some more paper clips and bent them into kind of like this little loop shape. Those are going to be targets that we can actually try to fish up from the depths. When we take our homemade Cartesian diver and place it into the bottle, screw the cap on nice and tight. Again, when you squeeze it, it's going to compress that air in the top of the straw, sending it, dive, and rises back up. Oh, I didn't get any clips. Let's try again. Dive. It's going to take some practice, but I'm going to practice this off camera, y'all. Try this at home and be sure to give us a thumbs up if you like this video. Try the experiment at home. It's so much fun. Also, be sure to subscribe to our channel so you never miss a new video upload, and check out the description below where we're going to be listing some science standards related to buoyancy. Also, there'll be information in the description on how you guys can help support us and keep the science alive. But right now, I'm going to go fishing for paper clips. Bye, y'all!
Too heavy.
Too heavy. Rise, my child.
Too heavy.